Hey, hello everyone. Welcome back. The last time we ended on network topology, where I explained a network topology to be configuration or arrangement of devices on the network. Now, I spoke about all these four types of network topology. I said the mesh topology combines all the above three topologies: the bus, the link, and the star. So the mesh topology, roughly, to tell you that is quite expensive as compared to each of them. I gave a pictorial diagram of how the network topology is like, where I explained what the star topology, the bar topology, and also the ring topology. There are advantages and disadvantages of each one of them, which we explained or talked about in class. Now, moving on to this activity, with this topic, which is the network device, I'm going to briefly explain each of these devices by talking about giving you the name and also explaining the function of each of these devices that are listed here. Of course, we are on network devices. Now, the first device I want to talk about is the network interface card, which is sometimes called network adapter. The network interface card is also abbreviated as NIC, NIC. An example, if you are asked what does this abbreviation stand for, NIC, you should know. For example, that is a network interface. Now, I'm going to reiterate by letting you know that the slides I use to present presents the lecture to you. It's totally not all inclusive, but covers about 90% of what the whole course is about. So I advise you go through the part of the official handout, which has been put on the via link, and for the general information section. You download it and go through it and read. I talked to you about this in class, but I want you to go through it. If you have any questions, go to the forum page and ask your question. Any of your mates will answer. I would also answer if I do see a question that is created by a student. All right, so moving on. The first network device I'll talk about is the NIC, the network interface card. So whenever you hear of a NIC, you think of it as an electronic component that enable computer to be on a network. So it comes usually in a variety of ways. So internal in a computer, or external. We also have wired type of network card, which is a interface card, this card, USB. Now, the internal network cards are the ones that are already inbuilt in the computer. An example is the wireless card that comes with laptop. So that is already inbuilt in your computer. You don't have to buy an extra wireless card to be able to use your computer to be on the network. So that is about the wireless card. Now, as I told you in class, when computers or desktop applications that you have in the lab, of course, it doesn't come with a wireless card, but it does come with the normal card which you will use your cable to connect onto the internet. So in the situation where you want to have your desktop computer in the lab onto a wireless network, you would have to get a wireless network interface card. And it could be in the form of a PCI card or a wireless USB. You can just buy a wireless USB, plug it into the USB port, and you have access to it. I'm sure I will show you. I've shown you examples of how some of these wireless cards are previously mentioned. Those that have issues, you can always go online and find out examples of them. Have a picture of them. In fact, let me see if I can even show you. Um, so when I say network interface card, so these are examples of wireless cards that are available. is the USB wireless card, uh, wireless card that you can slot in your laptop. This, you can put this one, that is a PCI format. You can put it in a desktop computer by mounting it in the expansion slot that I think I showed you in class. In our practical session, I'll go through it once again with you. All right, so the next one is the hub. I'm sure most of you might have heard of a hub. So when we say a hub, of course, we are still talking about network devices. When we say a hub, it's an electronic device for connecting multiple twisted pair devices together, making them act as a single network. So a hub are simple devices that forward all messages to every device attached on the network. So a hub, let me show you an example of how a hub looks like. So a hub looks just like a switch. We have so many different types of hubs available. So this is how the hub looks like. This is a USB hub. I mean, we're talking about network devices. Let me use network hub. All right, so this is how it looks like. You can see we have ports where you connect your cable, network cables. So for instance, with this device, I can have about 10 laptops. So let me count 1, 2, 3, 4, 5, 6, 7, 8, 9. Usually one is the internet, so this might be the port for the internet. So we have eight ports. So this is an 8-port hub, although it is 9. The ninth one is the one that says that probably will be the internet connection port. So this is an 8-port hub. So we can have 8 laptops connected to each port of this. So once you have all about 8 laptops connected to this, then we have set up what we call a computer network. That is how the hub looks like. When we go on, you realize that the hub and the switch look alike. The switch also has the same ports, the same ports where you can put your cables in there. We call the port RJ45. RJ45 ports, which we can use to connect your computer. This is a D-Link hub or switch, as you might term it. I'll explain the difference. So for this, we have, as you can see, this is a 5-port switch or hub. So the hub and the switches are more or less just the same. So in the same way, as I explained, if you have a hub, you can connect computers to each of them with a cable. Once you have all of these connected, then you have set up what you call a computer network, which will be classified under a local area network. I'll explain that before. Now, so a hub, as I said, is an electronic device for connecting multiple twisted pair devices together and making them act as a single network. So hubs are simple devices that can forward all messages to every device attached to it. Now, well, moving on, let's talk about the next network devices, the WAP, that is the wireless access point. Wireless access point. Now, for a computer to talk to, a computer that does not have any of the cables that we talked about. For instance, all these computers have RJ45 ports where we can connect our network cable on all of these. So assuming I have a laptop and I don't have a port where I can use a cable to connect and join this particular network, how do I do that? That is where we have the wireless access points coming in. So in that way, the wireless access points can be connected to this device. You can have the wireless access point, which is the WAP, connected to this device. Then it would distribute IP addresses to any wireless card that is available, just like your phone. If you want to get your phone connected to this network, you need a device called the wireless access point. So the wireless access point will serve as a bridge from your computer or your phone to the network card. So the wireless access point is a device that will migrate every wireless device onto the network. So it's a central device that connects wireless LAN to other LAN. So we have a wireless. Let me show you an example of a wireless access point. The wireless access point. So there is an example. Most of the time, some people say it's a router. There's a difference between a router and also wireless access point. But for now, for the purpose for your, because you're not computer science, for your purpose, we classify them more or less the same. So there is a wireless access point. This is also an example of a wireless access point. Indeed, this is the same as a router. And there's a difference between a router and a wireless access point. It virtually serve the same purpose, and a router has other functionalities that the access point does not. So if I want to connect my wireless device, be it my laptop or my phone, onto this network, then it means I have to have the wireless access point connected to the network first. So once this is connected to the network, then this will be able to give IP addresses to each one of the wireless network cards, which are on phones and laptops. So all those wireless devices will connect to this wireless access point, and this wireless access point will connect them to the network, which is this network, because it's connected to it. All right, so that is access point. So central device that connects wireless LAN, local area network, to other networks that connected our local area network, which is the wireless medium, to another network, which is found on the using cable. That is the one that I just showed you. So what you see, bridge. So that's like how you know of a bridge. You have a river. You want to cross over the river. You need to create a bridge to be able to cross over the river. So in the same vein, when you talk about a bridge or bridging as a network device, it connects two local area network segments and only forward messages that needs to go to other segments. So for instance, we have one network, we have another network. So there are two networks. We want to put them together. Let me go back again to this diagram. So we have, this is one local area network. We want to have another local area network, which looks exactly the same. How do we connect these two networks together? So two of this whole setup. One, another one that looks like this. How do we put them together? We put them together by a term what we call bridging. So we bridge these two networks together. By bridging, it means you're putting different networks together to share network resources. So that is a bridge. So a bridge connects two LAN segments and only forward messages that needs to go to other segments. So in our case, if we want to bridge a network that looks like this, one and another one, the only thing that we have to do is to use a cable. We can use the cable, any of the cables that we have in here. We connect it to this one, and we connect that cable straight to the duplicate of this, which probably will be located here. So in that case, the cable that we use to connect these two is what we call a bridge. So that is a bridge. And in that case, the bridge serves as a cable. So that is about bridging. So in networks, whenever I tell you, when a question is posed, what is bridging? You're connecting two networks together to aid in the sharing of resources. That is about the bridge. Now a switch, as I talked to you about, is just like a hub. So an electronic device that is similar to a hub but has capabilities to transmit data from one device to another directly. It is a multi-point bridge that connects two or more LAN segments. Now, as we've talked about over here, you saw how a bridge looks like. A switch, so this is a hub or a switch. I said a switch and a hub, they look so much alike. But the only difference is the switch is more intelligent than the hub. So in that case, if you buy a hub and you connect, assuming this is a hub, and you connect these five computers to it. If this computer wants to send an information to this computer, what will happen is this computer, the information that is sent on the information first will have to pass through the hub before it goes onto this particular computer. But in this case, for a hub, when you send a message, it goes to the hub. You send a message from your computer, it goes to the hub, and that message is broadcast to all the ports, like all the ports that are here, which is found behind this particular hub. So the information is sent to all these ports. Then these computers will now find out to see if the information being sent by these ones is meant for them. So in actual fact, they will all have a tip or have an they will all would have an idea of the message that has been sent. But this since the information is supposed to be located this one, it is to this computer. It is this computer that will acknowledge the receipt of the information that is sent. And that is an advantage. That is a disadvantage, mainly because an information that I want to send onto this one should not be broadcast to each of these to listen to it and know what it is, find out whether it is meant for them. So it is very easy for network hackers, to sniff packets or information that are connected to hubs. It's always um, it's not really the best of practice, but of course, if you have a simple network in your house, you can use the hub to work. But for a commercialized or an institution, it is always best to have a switch to do that. So that is one disadvantage of the switch of the hub. Now the switch, if this computer wants to send an information to this, the information is sent to this port, and the switch makes sure that it switches that information to the right computer to receive the information. Unlike the hub, the information is sent or broadcast to all the ports or all the computers before the right computer acknowledge receipt of the information. But the switch does not do that. When you send the information, it doesn't broadcast it. It sends it directly to the computer that needs to acknowledge receipt of that particular information that is sent by the first computer. So that is one major difference between the switch and the hub. The hub is not so intelligent. The switch is very intelligent when it comes to data dissemination and data dissemination. Hub is not so important, so intelligent. Now, when we talk of a client, a computer on a network that requests resources or services from another computer on a network is termed as a client. So most clients are workstations. So let me give you an example of how the client of a computer looks like by using the server client architecture. Server client network diagram architecture. So this is an example. We can have all these computers. There's one computer, there's another computer, there's another computer. So this is the server. So just like assuming this is our VLE server or the student portal, which is located at the ICT unit, you access the VLE server through the internet. Don't forget the internet is a bigger picture of a network. So in this case, we have a laptop connected to the internet, getting us some sort of information from the VLE server. So if you want to gain information, you want to access the VLE server, you go to the vle.zuma.edu.ca, browse through the internet to this, and this server will serve you information to your computer. So in this case, this is what is termed as the server, and it's more or less like a network device. So this is what the server any computer that connects or connects to retrieve information from one particular type of computer is termed as a client. So this is a server and it's serving um, its resources to these computers, which are termed as a client. In this case, the client is also a node because I told you any device that is connected to the network is a client, and of course this is also a node because it is connected on the network. The server is a node, the laptop is a node, the desktop is a node, the mobile phone is also a node. It's a node because they are all connected onto a network, which in this case is the internet. But in this type of architecture, these will serve as clients because there is a server that has some kind of resources that that these computers will need such resources. In that case, it will be a client to the server. So that is about a client. So when we talk of a client, we mean to say that it's a computer on the network that requests resources or services from another computer, which is also on the network. Once the computer or the server is not on a network, it can't give any information to any of these clients. So most of the clients that we see are workstations. I told you what a workstation is. The computers that are in the lab are also termed as workstation. Workstation can be a laptop, can be a desktop. The mobile phone can even be a workstation in one way or the other. Now I've explained what a server is. So it's a computer on a network that manages shared resources or services. It usually has more processing power, memory, hard disk space than the client. So from previous lectures, I explained what a server is when I talked about the microcomputer, the mini computer, and the macro computer. Now the router also works more or less like the access point, as I told you. It's just like the switch and the hub. So when you talk about the wireless access point, it also looks like the router. The router looks exactly like the access point. But the only difference is the router let me put it this way, it's a little more intelligent than the wireless access point. And the reason is when you connect onto the computer, so for instance, going back again to my architecture, previous architecture, going back to this previous architecture, when I connect a wireless access point to this computer, the wireless access point does not give an IP to any wireless device that is on the network, like your laptop or phone, but rather it only serves as a bridge to the network. So to get an IP to uniquely identify any of the wireless device, you need to have a server that has what we call DHCP, Dynamic Host Control Protocol. So this type of protocol gives an IP to any device that is connecting wirelessly onto the network. So in this case, the server which has the dynamic host control protocol, which assigns IP, will be the one to give an IP that will be sent to the wireless access points to be given to the wireless device that are connected, like your phones and the rest. So in this case, what happens is the wireless device, which is your phone, connects to a wireless access point. The wireless access point does not give an IP, but rather resorts on a server that has a dynamic host control protocol configured on it to give an IP that would uniquely identify any wireless device on the network. However, when we talk of a router, what a router does, like your MTN router or TurboNet and the rest, what a router does is it doesn't need a server that has a DHCP installed on it to give an IP to uniquely identify a wireless device. But rather, the router itself has an inbuilt DHCP, which is the Dynamic Host Control Protocol, that automatically serves to any wireless device that connects. When you take your phone and you connect your phone to your wireless to your Turbonet or MTN router, the router automatically gives you an IP address without having to consult a server that has a DHCP, because the router already has a DHCP installed on it. So it will give you an IP address. Then when you want to go onto the network, it now moves your information based on the IP address that is given to the network that it is connected. So that is how the routers work. Just the same way, when you pick your phone and you want to connect onto the network, what you normally do is you put on your 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 hotspot. So in this case, your hotspot will give your computer a unique identification, which is an IP, for you to connect onto the internet. So the hotspot, your phone will now serve as a hotspot, which will also serve as a router to give you access. So what a router does is it moves a network, wireless network, or any network device from one network to another network. So that is how the router works. So it's a device that provides paths for messages through several connected networks or to a one. So the router, as in router, most of the time has two network cards. So for it to route you from one network, which might be the internal network, to the external network, which is probably the internet. Client computer. So as I've said, user computer for surfing the network. Server provides network services and resources. The gateway, a device that connects the LAN to the WAN, a device that connects you from the local area network to the wide area network, so that data can be sent from the local area network to external network, which is the wireless area. So for instance, anyone who is connected onto the university network, if you want to browse using the university network has what we call the local area network. So once you connect onto the university network, you are automatically given a local IP address. So if you want to go to the local IP address does not give you internet access, but gives you access to local network. So anytime you want to go onto the internet, we have what we call a gateway server, which is more or less the proxy server. That will now move all your local area network connection or IP onto a different network that has internet to give you access to the internet. So that is the gateway. So it's a device that connects the local area network to the wide area network, which is the internet, so that data can be sent from the local area network to the external or the internet. Now there are types of networks. Now, as I spoke to you about in just a brief in the previous slide, I spoke about the local area network, which is a network of computers and other devices that are defined in a relatively small space. So in UMAT, we have a local area network based on the geographical location and the demarcation on campus. We have what we call the local area network. If UMAT campus is, we have another campus, which of course you know is Chicago. If we want to connect to that campus, we would connect it via what we call a metropolitan area network, which is a MAC. Depending on the geographical location, we can also call it one. It depends on how you want to say it now. For example, if you don't see a man and you see a one to work, because there are two different networks which are geographically dispersed at different places. So when you get them connected, it becomes a wide area network or a metropolitan area network based on the demarcation of the area. So local area network, which is LAN, is a network of computers and other devices that is confined to a relatively small space, such as a building or even one office. So when you set up a network in your office, sorry, when you set up a network in your office like this one, if you set up a network, this is just an example of a local area network. All right. So IEEE, which is developed, I would it wants you to find out the full meaning of IEEE. Since we're here, let us do it together. So IEEE, yeah. So sorry. So it's an institute of electrical and electronics engineering. The Institute of Electrical and Electronic Engineers. So that is the IEEE. So these individuals are responsible for most of the network types that are available. So the IEEE developed these standards and term them IEEE OH. Whenever you hear of IEEE OH2, then it means we are talking about network devices. We're talking about network. So it is a family of standards for LAN, which is a local area network, and metropolitan area network, wide internet. Now there are about 5 types of LAN which are commonly used here. We have the contention bus, we have the token bus, we have the token range, as you can see, bus range. We have the Wi-Fi, we have the WiMAX. Now these last two, the Wi-Fi and the WiMAX, are what we normally use. So those are the ones that we talk about. You can see each LAN types have their IEEE number. So we have 802.3 for contention bus. You should know what it is. When in an exam we say 802 IEEE 802.4, what type of network is that? You should be able to know that it's a token bus. When we talk of 802.11, we are talking about Wi-Fi. When we talk about 802.16, we are talking about WiMAX. WiMAX, that is what the internet service providers normally use to broadcast connections to each of the masts that we already have, that we see on campus and everywhere in the country. So these two are the ones that we normally use for network. Um, Two types of that are commonly used LAN. All right, so that is about the local area network, confined to a small location. When we talk of a wide area network, which is termed as WAN, the network that connects two or more geographically distinct LAN. So that is, I give an example that we have one campus here, we have another campus in Chicago. So the campus network that we have in Newmark is what we term as a local area network. The one that we have in Chicago is what we term as the wide. It's also a local area network. When we connect these two types of local area networks that are geographically distinct together, then we have what we call wide area network. So just like the banks, they can have one branch in Takwa, like other commercial banks, they have a branch in Takwa. We have another branch in Accra. So these two local area networks, one is the local area network of Takwa, the local area network of Accra. When they are connected together, we term them as the wide area network. So in fact, most organizations use the wide area network to connect separate offices, whether the offices are across town or across the world from each other. So even if we have one in Ghana and one in Nigeria, like Fidelity Bank is being in one office in Ghana, and also have there is another Fidelity Bank in Nigeria. So if these two banks want to talk to each other, the connection, these two local area networks, when they connect together, we term them as wired area networks. So the internet is an example of a very intricate and extensive wide area network. So we have so many wide area networks coming together to form what we call the internet. So, and this usually spans the globe. So we have so many wide area networks connected. Once you have all these connected geographically, it will come together and serve as the internet. So the internet is more or less the mother of all one. So this is a typical example of how the network are explained for humans and schedule and office from Ghana Commercial Bank and maybe another kind of interquire and also in Accra. So you can have a file server here. We have our LAN, we have our router, we have the clients connected in the local area network, a commercial bank in Takwa. We have a commercial bank in Accra. So how can these two networks that are local area networks talk to each other? You will need what we call the router. This is the router. I told you that a router moves network devices in its local area network to another network. So the whole of this is a local area network. If we want to talk to this one, we have the router will now have to put all these ones which are connected to it to this router to be able to talk to it. So that is what the router does. It routes one network to another network. So in this case, it will route the network here with the local area network to another network, which is also a local area network located somewhere at different geographical locations. So comparing LANs and also WANs, these are some of the things that you should be looking out for in terms of the characteristics and also local area network and the wide area network. So when we talk of the characteristics, geographic area of coverage for a local area network is localized to a building, group of buildings, or company. For a wide area network, can span any area range in size from city to the globe. In terms of data transmission rate characteristics, um, typically the local area network have 4 megabits per second to 60 megabits per second in terms of the data rate. The data, the transfer rates from one point when you're downloading on the network. So for a local area network, it probably would be from 4 megapixels to 60 megapixels with high speed internet and also fiber optic based operating at 100 megabits per second and also 1 and 10 gigabits per second. So the switches that we have most of the time in the local area network are usually 100 megabits per second and also 1 megabit per second. In less situations, you might have 10 gigabits per second. Now, for the wide area network, still under data transmission rate, we have what we normally term as T1. We normally operate at or below T1 and E1 transmission rates of 1.55 megabits per second, and also 2.048 megabits per second. This is in relation to the transmission speed rate. For the error rates, these are the error rate values that have been categorized under the local and the wide. So please take note and know the values of each of them. For ownership, in terms of the ownership characteristics, usually with the implementer under local area network, the communication carrier retains ownership of this line facility. So who owns the local area network? Anybody who implements it on their network owns it. But when we talk about the wide area network, the communication carrier retains ownership of the line. So to be able to connect the local area network of Tapa JCB to the communication company that does the connection based on the route, the one who owns the internet, who owns the connection or the network. So in that case, Vodafone can just terminate this one, and your connection from Takwa to Accra will not be successful because Vodafone owns the connection for you to link you from your Takwa to your Accra. That is why most of these internet service providers are the ones that provide us with one, which is a wide area network. Anytime we talk about that, so you should be mindful of that. But in terms of one, the ownership is for the carrier, that is the internet service providers, Vodafone, MTN. If you do the connection from Takwa to Accra, They are the ones who own the network. So data routing normally follows fixed route, but when you're routing with a local area network, everything happens within your local area network. The wide area network switching and capabilities of network allows an alteration of data flow. So there is some sort of switching. You need to switch one network to the other through the router. So some of these things are done by the internet service provider. We also have topology as a characteristic. Usually, let's as the tree or star. You can see there's an introduction of a new topology tree. The tree looks more like that. The tree has a lot of branches. Previous ones I talked about the mesh being a combination of bars and stuff. But for a wide area network, virtually unlimited design capabilities, you can have so many of these topologies that are put together. So that is where the mesh topology really will come into play. You can have the bars, the ring, all implemented together at a wide area network by the internet service provider. So for a characteristic like the type of information carried, of course, in a local area network, that is where the primary data is carried on. Most of these primary data be in any form. But for the wide area network, you can have voice, data, video commonly integrated into the wide area network to make it easy for us to connect to each other. Still on the internet, I explained earlier. Let me just give a recap of it. So the internet is a network of networks. It's a network of networks that use the TCP/IP protocol, the transmission control protocol, and internet protocol. So that is this type of protocol is being used by the internet to fetch and get us information that we need online, which is quite similar to the enormous one that we already know, that the wide internet. I told you that a combination of all this is the internet. The internet is more or less the mother of all one. The internet can also be defined as a worldwide network of computer networks that together work to share information resources and also technology. So these are the types of, remember I talked about the network adopted. Network interface cards is an example of one of them. So for this particular one, we have the PCI Ethernet adapter. So we can have RJ45 somewhere here. As you can see, triple pair. That is where we have the triple pair cable entering into the network. So this is also an example of a PCI 802.11 for the wireless connection. And these are all examples of wireless cards and wireless and cable network cards. So briefly, let's talk about the internet and the World Wide Web. So the internet, as the name suspiciously suggests, can be defined as joining several networks or large networks of computers, geographically distributed computers, on site and also in country. So for a computer network, so in this type of network, we have computer networks of two or more computers linked or connected together by cable, be it electrical, phone lines, fiberglass, fiber cable, microwave, there is a microwave that the service providers provide, radio, or even satellite. So those are ways that we get connected onto the internet. So the computer participating on the internet are global or publicly identified using a unique IP address. It's the 4 digit. So the IP address. So when you connect your laptop to your phone, you can see you have some numbers 192.168.1.1. So you have 192, which is um, one number. So it's a 4 8 bit digit. So if I have, let me put it this way, if I can write it here. I have one, two, six dot maybe 21. So the 192 that you see here, 192 that you see here, another this is the dot 192 dot 1.1 dot 1.6 dot 21. So I told you, so you can see there are four segments. You have one, two, three, four. I told you the computer only understands zeros and ones. So this is an example of an IP address, and that's the only way a computer is able to uniquely identify an element. So the computer only understands zeros and ones. So for this to be understood by a computer, it needs to be converted to binary. So when you convert this one to binary, you know of your ones and zeros. It will give you about 8 numbers, 8 bits, which we term as 1 byte. So we have 8 bits equal to 1 byte. And a byte is a character. A character. A byte is a character. A byte is a character. So this will be converted to 8 bits, which the computer will understand. If you convert it to base 2. And from what is being said here, says the World Wide Web. Sorry. Yeah. So the computer participating on the internet are globally or publicly identified with a unique IP address. So we have 8 bits. So if this one is converted to binary, we get 8 digits. This one 8 digits. 8, 8. So we have 4 of them, or 8 bits, or a uniform resource locator, URL. So the URL, that is a uniform resource locator, which users can use to search or research them. So for instance, if you want to check out UMAT website, this is what we call the domain name. And the domain name is also termed as the URL, that is a uniform resource locator. So it is this that you type in your browser to get access to the UMAT website. Now, the domain name, as most of you are aware, when you type it into the browser, it always starts with H starts with HTTP ::/. Now the HTTP is the protocol. The whole of this is the protocol for the internet. So this is the protocol. This is termed as a subdomain. Sorry, a subdomain, and the whole of this is the domain, human.edu.ch. But this gives you the domain, the extension for Ghana. So the whole of this is the subdomain. The whole of this is the domain. So if you have umat.com, the .com is the highest domain, and lots of them. So this gives you the protocol. This gives you the subdomain. And if you have a file maybe called index.html, this will be a file or the path to the address that we want to locate. All right. So that is about the URL. So the World Wide Web, this is the WW, is an architecture framework for accessing linked documents spread out over millions of machines all over the internet. So on the internet, we have information that is stored on computers called servers. So the VLA server is able to store some information. There are different types of servers that are also available. Now, the World Wide Web, or the web, which is normally called, is a system of internet servers. I explain what servers are. That supports a collection of documents that are written and formatted using the same type of programming language called hypertext markup language. So virtually all this, when you visit a website and you try to check out the source code of the website, what it gives you is what you term as the HTML code, the hypertext markup language. So all the websites that you see, if we should look out for its basics, the basic programming language that is used is what the markup language that is used is the HTML. Now, still on the internet and the World Wide Web, you can see that these documents or websites are created you when you enter the website address in your browser. And the reason is you are actually sending hypertext transfer protocol, which is the HTTP command, to a web server, directing it to find and transmit the request that you put in the address bar of your browser. So, for instance, we have this server abc.com, and we have this server xyz.com. These two are all web servers. You can see they are web servers. They have, because they are web servers, they are just like a computer. They have disk, they have RAM, they have CPU, they have everything that a computer should have. So, assuming there is a client here, or this is you using your laptop or your desktop, you are the client. These servers are the ones that are going to serve you with information. So, your current page displayed by the browser. So, you open your browser and you want to find some sort of information from the abc.com website. So what is displayed here, you see something we call the hyperlink. Hyperlink is a link that is hyper. If it is hyper, so it gets hyper whenever you hover onto a text. So you hover over the link, like let's say about us, you hover over it, and you see the hand symbol. You see it change to a hand symbol, meaning it's ready to be clicked to link to something. So when you click on it, it goes to ABC web server. And assuming so this is the browser located on the computer. It goes onto the ABC web server when you click on the hyperlink. And assuming there are other things that are also on the ABC server that is being requested, like what you are looking for needs to be requested by this server to a different server. For instance, on the UMass website, or we have YouTube linked with UMass website. So when you go to uma.edu.ch, uma.edu.ch server also talks to YouTube to display some information for you. Let me use this example. So when we come to uma.edu.ch website, you can see it is saying waiting for uma.edu.ch at the bottom left. So at the bottom, you can see we have some videos. These videos, as you see here, are on YouTube. So these videos needs to be retrieved from YouTube website for them to be displayed on the UMAT website. So in the same way, you go visit uma.edu.gh. The site, the web uma.edu.gh server is displaying the content for you to see in your browser. But there are other contents that are not in the uma.edu.gh web server, but needs to be retrieved from another server, which is Google YouTube.com. So these information are coming from YouTube.com, although we have linked it with the UMass website. So in the same vein, you you click on a hyperlink to retrieve information. ABC also tries to see that, okay, there are certain information that you're looking out for. It is not here, but it has been linked with our website. So it also goes to the abc.com server to retrieve the information to this one to be displayed to this particular client's computer. So that is how I just explained. So the browser uses what the connection type as the TCP connection, the transmission control protocol, as I talked about. This is the web server. The browser always talks to the web server, and that is how it works. Okay. So these documents, as I've explained, or websites are retrieved and viewed when you enter a website address in the web browser, mainly because you are actually sending a hypertext transfer protocol command to the web server, directing directing it to find and transmit requests of web page. So if that is a typical example that can give to explain that. I've already spent almost an hour, so let me just go to the other. Now, the internet and the World Wide Web, um, still on it. So using your computer to tour the World Wide Web is called browsing or surfing. So if you open your browser and you want to go to any website, Facebook, Twitter, and the rest, we term this as browsing, or in other words, surfing the web. So sometimes you'll be looking to see what is there. At times you'll be looking for something specific. So in essence, a browser is a program that can display a web page and catch mouse clicks to items on the desktop, to items on the display page. So the example that I gave, this is the website. This is the browser. The browser I'm using is Google Chrome. This where I type the yuma.edu is the web server, is the address bar. Now inside you can see I have the protocol that is being requested is HTTPS. So that is the protocol that helps serves as web content. HTTP stands for Hypertext Transfer Protocol. The S at the end means the website is secure and using something we call SSL certificate, which is termed as SSL is an abbreviation for Secure Socket Layer. So the S here for this protocol tells us that the website is secure. That is how come you can see a locked symbol. So when you click on it, it tells you your connection is secured. There are some sites when you visit it, you might not see it as secured. I explained in class that when you are visiting such websites and you're doing online transactions, you have to be very careful. If not, your credit card details will be stolen. So when you go to a website like, let's say, this was th.com. Let me use this website. Let me use this for instance, faculty and stuff. You can see it says it's not secure because we have not configured it to give HTTP, to use HTTPS. Now, if you go to a website that require money or request for your information and it is not secure, you have to be careful what you do with that website. If not, by the time you realize hackers are sniffing around and stealing your credit card details and your information. So always be on the lookout for a secured website. When it's secured, you get it locked, telling you it is secure. This is not this particular web page is not secure because we are not really taking out any information from anybody. So it's not much of a big deal. All right. So that is about the surfing. So in essence, the browser is a program which I talked about. There are so many browsers that are available. I use the one that I just showed you was Chrome. Others use Mozilla Firefox. There is Edge. There is Internet Explorer. There is OD browser. In fact, there are lots of browsers that you can use to surf online or to browse online. Now, when an item is selected, the browser follows the hyperlink and fetches the web page. So as I said, so you can see this is a normal text, but this particular text is hyper. So that is how come I'm able to click on it to get what we call a hyperlink. So you can see there is a hand, but these ones does not give me a hand. So this takes me to a page where it links me to a different page which is located on the web server. So that is about how hyperlinks work. So therefore, what you should have in mind is the embedded hyperlinks need a way to name any other page on the web. So if there's text, I want to go to a different page, it needs what we call the hyperlink. Hyperlink will convert it to the hand symbol to make it easier for you to click on it. So pages are named using URLs, which is the Uniform Resource Locator. And a typical URL is http colon // www.abc.com / product.html. So this is the protocol. This is a subdomain. This is the domain name, and this is the top um, the top domain name that is given. But you find all these in the text. And this is the location of where I really would want to go, the product.html. So it's the path to the product.html. So generally, if you want to browse in browsing, these are some of the steps that you go through. Most of these you already know. So I'm going to go through it as quickly as I can. To begin browsing or surfing the internet, you must have the following: a physical connection from your computer to the internet, such as the modem through a telephone line. So a modem, as I already know, is a hardware that your computer uses to send and receive information on the internet through standard telephone line. So again, the modem also helps convert digital signal to and from analog signal. I remember explaining this to you in class. Why a modem is classified as an input device and also an input device. Because it modulates, that's the first one, MOD, it modulates and also demodulates signal, either digital to analog or analog to digital. That is what makes it an input and output device. Now, the ISP, which we normally term as the Internet Service Provider account or Internet Service Provider account, so an ISP serves as an entry point to the internet, to the world, to the web. So to have access to the internet, we always need what we call the ISP, which is the Internet Service Provider. And in Ghana, we have lots of them. We have Vodafone, we have MTN, we have, I think, Surfline. In fact, there are lots of ISPs that give us access to go onto the web and get connected onto the internet. So in that case, in UMAT, we have two ISPs. We have the Garnet and we also have Vodafone. I remember telling you that some time back, somewhere about 10 years ago, we used to have our internet service provider located in India. We call them Jila. And we were so you asked me, okay, how do you get internet access way from India when we have Ghana? So at that time, they were giving us internet through the satellite medium. So those that have been to the ICT unit of that building, see there are two satellite devices that are located on top of the building. So that was what was giving us internet at that time. Our service providers, which is the internet service providers, were in India. But now, of course, Vodafone is around. They've given us fast internet connection using the fiber optic cables because light travels faster. Fiber that with optic is light. Light travels faster than any other connection. And again, the satellite connection, we also realized there were some issues with them. So in that case, when it rains, there is a disruption in the network. The signals get disrupted in a way, so you're unable to browse anytime it rains heavily. So those are reasons why we had to find a way to switch to Vodafone and our current one, our second internet ISP. So a browser installed on your computer. So what a browser does is a software designed to locate and display web pages. Browsers are designed to read hypertext markup language, which is the HTML, that is the markup language, that all websites, that forms the basis for all websites, which is simply the authoring language that is used to write web pages. Microsoft Internet Explorer 567. All these are examples of web browsers. There are different brands that are available. There are some that are not even located here. So all these are web browsers. Now, in terms of searching for information on the internet, there are two main ways of searching search information. The first one is through search engines, and also the second one is through portals. So for search engines, the first step is to search for information. To use anytime you want to search, the first step in searching for information, you have to use what we call the search engine. So a search engine is a type of program found on various websites that allows you to search the internet for keywords or type in. You remember when I was looking for the network router, I went to Google search engine. I typed in network hub, network router, network access point to get all the information. So the search engine will return a list of web pages or images that have your keywords in them. So that is the search engine. Of course, users will use one or more keywords to search for the desired information. Then the search engine will search for websites based on the keywords that the user enters into the search engine, like Google. For portal, the second best way to access information is to use portal. A portal is a server that contains a directory of several servers on the internet based on categories of information available on the web server. So this deals with web servers. The portal, as it says, is a server that contains a directory of several servers. So that is another way of getting searching the online for information. Now, emails will be done very soon. Emails, electronic mail, email of course stands for electronic mail. It's a form of mail delivered over the internet. So unlike the snail mail where you go to the post office, you put in an envelope and everything is sent via courier service to maybe wherever the recipient is. With email, that is not what is termed as a snail mail. Snail mail is a normal post office mail kind of thing that we do. But with email, is a form of an electronic mail delivery over the internet. So it's like a paperless letter that goes directly from one computer to the other. So to get an email, both the sender and the recipient must have email addresses. So in the same way, if you want to send a snail mail using the post office um, strategy, then you have to find a way to know the address of the person who received the package or the mail that you want to send to him or her. So for the electronic mail, you need to have the recipient's email address, and the person who is also sending the mail should also have an email so that the recipient can reply to the mail. So accessing yahoomail.com, Yahoo Mail um, um, is an example. So we have so many email serving companies that are giving us access to the email. Gmail is a typical example. We have Yahoo, Hotmail, but there are lots of them. So these companies give us access to a small portion of their service where we can send email. So Yahoo Mail is a web-based email. This means that your Yahoo or your Gmail or your Hotmail account is actually a website residing on Yahoo Mail, Gmail, Hotmail service. So with your Yahoo ID or your Gmail ID, which is your email address, you can access your Gmail or your Yahoo messages using the web-based Gmail or Yahoo client from your computer, which is the browser, with an internet connection and also a browser. You have access to your Gmail or your Yahoo or your Hotmail. So in sending the mails, you can use your Yahoo, fact, we have more of Yahoo and Gmail and all of that. You can use your email account to send emails and receive to any valid email address. So you send same email to up to 100 people at a time. So to send your message to more than one person, add additional email addresses to the two sessions. So let me use an example. I want to use one of my mails to demonstrate quickly. Let me use this one. Yes, so as I was saying earlier, I said message to more than one person. So this is an interface of a Gmail environment. If you want to send an email to somebody, you click on Compose. So these are some of the things that are available in Gmail. So you have the inboxes where all the your new mails reside. We have the important. So this one has been tagged as important. It means so important to me because I've been working with the web hosting bus company. I've been talking to them anytime we have issues and all of that. So we have the sent message gives you um, the messages that you have sent from your computer or from your email to other people. So these are all sent messages that I've sent across to people. The recent one was somewhere on the 11th of November last year. All right. So the inbox is where all new emails will come. So assuming I want to send an email to somebody, what I'll have to look out for is to click on the compose. So from the compose, that is where I get a chance to send emails to people. So from here, I'm saying that if you want to send message to more than one person, so assuming I want to send an email to this person, this is me. Right after typing this one, um, I can still type another person's email. Let's say me@me.com. In fact, this is not a valid email. So I can type as many emails as possible. Now you can see we have CC and BCC. The CC stands for copy. So in the same way, where I have two, I can just copy and send an email to maybe you@you.com. Sorry. So it means I've copied the mail to this person too. So when I send to this email, this person will also get and see how it has been outlined. Now the subject is a brief summary of what you want to talk about. So for instance, I'm just testing. I'm just testing how to send an email. I can just say testing email so that before the person opens the mail, he has an idea what the mail is about. So for instance, you can say Google My Business, web hosting. So this web hosting, when I see web hosting, I know, okay, this is coming from this web hosting company that I have to sort out things with them. If I see Google, so these ones that you see are the subjects that are shown over here. Now, at this point, that is where you begin typing the email. So this is just an example of a test email, email to be sent to the above the email address. Yes. All right. So that is how this is. So this is the subject area. This is this is the email itself. This is the subject, and this is the recipients of the email. So I talked about CC, that is the copy, and the BCC. When you click on blind, and BCC stands for blind copy. Blind copy, what it means is, if I should blind copy this person, let's say us at us.com. What it means is this email will go to these recipients, but they will not know that I've copied us at us.com. They will not know that this person is also receiving the email. So, assuming you want to send an email to your lecturer and you want to copy your friend, you don't want your lecturer to know that your friend is also copied in the email. You can blind copy the person by using the BCC. So in that case, your lecturer will see the mail all right, and he will see that he's the only person who has access to the mail. However, the lecturer will also see the mail and would know that uh, you sent him a mail. It will make it look, the email will look unique to him because he will think, okay, you sent this to your friend. Your friend will know that you sent it to him alone. Your lecturer will also feel that you sent it to him alone. So that is the essence of the blind copy. Now, since we are here, let me quickly show you something which we call signature. So there are times you open an email address and you realize that anytime you compose an email, I'm going to open one of them. Anytime you compose an email, you see something different. Sorry, just give me something for you. Okay. All right. Let me just use this one quickly. So this is my personal email. Let me just use that. So assuming I compose, I click on compose. My network is misbehaving a little. Okay, assuming I click on compose, we have something we call the signature. The signature, so this is an example of a signature. You can see I didn't type all of this. I didn't type all of this. This is my old signature. I think there is a new one. Let me see if I can get that one. All right. So if I click on compose, that's just a little slow. All right. So you can see, okay. When I click on compose, hmm, okay. So at the compose, you can see I didn't type any of these, but automatically this came. So this is what I want to show you. So you can see I have best regards, my name, some qualifications, and all of that. So how do we do this? This is the way forward. Now, this does not have the signature. The signature is something that always pop up in every time you try to send an email to a person, and that is more like um, giving your designation, what you do, and all of that, some general information without having to type them, as you can see over here. So this is an example of a signature. So to do that, you can go to settings, and pardon me, I think the network is quite slow. Then you look out for all settings. Then at the bottom, you can see this is where we have the signature. This is where you type in your signature over here. No, this is, there are so many things that you can do here. If you are on vacation, you can activate this and put in a message here. I'm on vacation, I'll be back in 22 hours or 21 days. So anybody who sends you an information, an email, an automatic email is sent to the person telling the person that you're on vacation based on what you type in. That's a vacation email. Now for the signature, yes, so this is where the signature is. So there is no signature for this one, so I can create a signature. I call it maybe UMAC. So you can see a signature has been created, and I can now type in anything I want over here. So in this case, I can choose to copy the whole of it, paste it in here. All right, so let me try and save this one. So I'll save, but I'm not on vacation. I have to do it. So now when I come to testing, so let's forget about me sending this mail and I create a new email. I hope I save the signature. I didn't save it. Okay. All right. So for new emails, use this signature. On reply, maybe if you have different signatures, you can talk about it. Insert signature before quote text in reply. So I'll check that one. And I'll save. So now this is saved. So anytime I click on compose, I should see my signature in here. So from here, I can send an email to me at me.com. The subject is test, test, whatever. Then you type your actual message in here. This is just a testing email. I spoke to you about the blind copy and blind copy. So if you want to blind copy somebody, you also do something. You type their email address in there. The blind copy will make sure the other recipients will not know that you sent an email. So right after this, I'll click on send. If I want to attach some sort of information, I will click on attachment, those pictures or whatever. I'll attach all of them. Then I'll click on send. So that is about our slides. That is about emails, sending emails. I've combined everything and talked to them. So I've talked about the copy and the blind copy. Blind carbon copy as you saw. And attaching files, I've spoken about it. Most of these you already know, especially mainly because you have phones that does all of that. So we have inbox, we have drafts. So the information, the email that I was sending earlier that I didn't send, it will be saved in draft. And if I send, it goes to the sent message. The trash is where all deleted emails of your Yahoo email reside. If you delete a message for the first time, or you delete a message, it resides in the trash or the recycle bin, which is the computer. For this case, in an email, it goes into the trash and it stays there for 30 days. If you don't retrieve it, it's permanently deleted. So that is about the trash. The bulk, the first time you receive message that the spam guide utility identified as junk mail, it creates an additional permanent folder called bulk, where it stores these messages there as a main. So there's an example of what I just showed you. Compose the inbox graphs. You can create, in fact, you can create any of the labels yourself, as many labels as possible. So the spam is where um, spam messages are sent. The trash is where deleted messages. Day in, day out, new things keep coming in. So you will see a little difference in terms of the interface as compared to yours. So working with folders, so you can create folders and put in stuff in there. These ones I've explained. Moving messages from one folder. You have a message over here that you can see all these messages. I can check these messages and drag them probably to maybe the travels folder. So that folder, it means um, messages that I think are related to maybe Google. I'll put them in a Google folder so that it becomes easier in terms of file organization. Locate them. It helps in file organization as well. Working with folders, these are all some of the things that can be done with them. Okay, so sign it out by clicking at where your image is. You can sign out and return to your email anytime that you want. And this brings us to the left end of lecture 6. If we were to be in class, I would have told you to give me a general summary by students. Unfortunately, we are not in class. So thank you. So this brings us to the end of lecture 6. I've ended the computer network. As I introduce you again, go back again to the handout, which I've already put on the VLE. Let me quickly display it to you so that you know exactly what I'm talking about. Make sure you do that. Make sure, let me sign in my account, not the administrator. Please, this is very important. So I advise you go to the VLE dashboard and look out for intro to computing, and make sure you read this lecture material. This is a PDF file, which is about 100 pages. So all the lectures that we've talked about, they are all there. Maybe next week we will have a quiz. So please, the lecture materials, these are the PowerPoint. This is the PowerPoint. This is the PDF of the full lecture material. So I would want you to visit it and read it alongside what I've talked about in class with the PowerPoint slide. So all these, go through them. Windows 10. Next week, we will continue with practical session. I spoke to one of your the class reps that I really would want to teach you how to develop the site. So let us try to do things as quickly as possible. When we are done, I'll just use a lecture or two to teach you how to develop a website. Thank you very much. So that is a giveaway for you anyway. Thank you and have a good day.